Hello my fellow mathematician, welcome to the study of ordinary differential equation, and we are looking at the exact differential equation. So the first thing we are going to do here, it is to rewrite our given equation so that our equation can be of the form m of dx plus n of dy is equal to 0. So that is the first business we are going to have here. So you can cross multiply. We are going to multiply it this way, and this other part that way, to obtain 1 minus x squared of y, that is d is equal to x of y squared minus 1 dx. Then we can take dx on the other side so that we obtain the following result. So we are going to have 1 minus x squared of y dy minus bracket xy squared minus 1 d of x is equal to 0. Once we have done that, then we write our m, which is a function of x and y. M, it is the function which corresponds to where dx is. It is negative bracket x y squared minus 1. Then you write your y, which is also a function of x and y, which is the function where dy is. It is 1 minus x squared y. Once you have written those, then you get now the partial derivative of m with respect to y. You differentiate function m partially with respect to y. In this case, we are going to get 2xy when you differentiate this. Then you get partial derivative of n with respect to, and this is negative, sorry, there is a negative there because of this negative. Then you differentiate n partially with respect to x. You are going to get, in this case, negative 2xy. Then from there, you compare the partial of m with respect to y. If it is equal to the partial of n with respect to partial of x, in our case, it is equal to negative 2xy. That if the result are equal, partial of m with respect to y is equal to partial of n with respect to x, then that tells you that your equation is exact. So if your equation is exact, then you employ the following method to solve it. You employ the following method of x of y is equal to c, and partial of f with respect to x dx plus partial of f with respect to y dy is equal to 0. Then we compare now our partial of f with respect to x is equal to what we are given there. In our equation, it is the part which has m. It is negative bracket x of y squared minus 1. That is what we are given. Then from there now, you integrate this equation. So partial of f is equal to negative bracket x y squared minus 1 partial of x. So you integrate this equation both sides to obtain the following. The result will be a function which is a function of f of x, f of xy, which is equal to, we integrate this equation here with respect to x. So here we are going to get negative x squared y squared over 2 minus x plus a function which is a function of y. You can call this equation 1. Then you differentiate equation 1 with respect to, partially with respect to y, to get the following. This will give you negative x y, which is squared, because this y you multiply by 2 and you divide by 2 to be left with this, plus g derivative of y. Then you compare with this, df of dy, which was given, is equal to, so comparing, our df of y is equal to negative x squared y plus g prime of that. So On the left hand side, they are equal, so we are going to have minus x squared y plus g prime of y is equal to 1 minus x squared y. So you can see 1 minus x squared y are common, which will cancel, so that you are left with g prime of y is equal to 1. Then we integrate this equation both sides. When you integrate g prime of y, you are going to get g prime of y, which is equal to y plus constant c. You call this 2, and you substitute your 2 in 1. You substitute your 2 in 1 to obtain the following. F of xy is equal to minus x squared of y squared over 2 plus x plus y plus constant c. If you want, you can check you are working. You can check by differentiating this equation partially. So you have d of f of x. This will give you negative x y squared plus 1. Then you can get df of y, which will give you also negative x squared y plus 1, which is equal to the equation given above there. So that is equal to the equation given there, meaning that our solution is correct from what we have found out here. So thanks so much for taking your time to study with me exact differential equation. For more such equation, kindly check in my YouTube channel. Also, if you are there and you have not yet subscribed, I request you to do so that you don't miss a single video which I upload for us every day. Bye bye. See you in the next study.